Okay, let's pick up where we left off with the previous video. We did the first part of this problem, where it said use differentiation to get a power series for this guy, and then use that result to get a power series for this guy. So we're going to go focus on getting a power series for this guy, get a destination here from the power series for this guy. And they do seem related, like if I differentiate this, I should get there. So my destination is this h of x function, and we were directed to use this previous result. So I should be able to trace this guy somehow, or trace this guy from back to this guy, and we do get a feel for if I differentiate this again, I'm going to have a 1 plus x to the third popping out in the denominator. So let's go say, let me start with this. Let's have a guess of using this. So my guess is to start with, so I'm trying to find the function h of x power series representation, and I'm using this. My guess was, okay, let me just start with that. I started with that, and when I differentiated it, I got this, which sort of looks like that, but it has this additional -2 that's bothering me. I don't want it there. So I'm going to amend my guess and divide by that -2 so that I don't have that popping up for me and causing issues. So again, I repeat, I amended my guess, and instead I'm going to use this g of x, because when I differentiated it, I had this additional -2. I divided it by -2, or multiply by -1/2, same thing, and that would nicely get me to my destination. So I need to get a power series for this guy, but good news is we already have a power series for this piece. It's right here. So let's go plug that in and clean things up a little bit. So I'm going to have -1/2. I just replaced this guy with its power series representation. Now I'm going to go put in the -1/2 inside, I guess. So I moved in the -1 with this guy, and that made it -1 to the n plus 1, because I gave it one more additional -1, and I just put the 2 in the denominator. So this is my g of x equal to that power series. I'm going to differentiate both sides with respect to x, because I know this guy is going to lead me back to my destination. And when I put this as 1 plus x to the -2, and I differentiate, bring down the -2, knock down the power by 1, and don't forget there's a chain rule involved too that we're not really showing, because the derivative of the inside 1 plus x is just 1 anyway. These guys cancel out because of that original amendment I had made, and now I get this guy, which is really my destination h of x that I was trying to get to. Okay, now let's go take the derivative of the right side. So the only thing again that I'm really focusing on is the x's, because I'm differentiating with respect to x. So I get -1 to the n plus 1 stays the same. Since I differentiated it, I lose the constant term, so I'm going to up it to 1. The n plus 1 over 2 stays the same, and I'm going to differentiate this piece, bring down the n, x to the n minus 1. Okay, so we're pretty much there. We have a power series representation for this guy. I can go ahead and maybe do an index shift here and put things in terms of x to the n. So since I want x to the n, I'm going to up everybody by 1. Okay, so upping everybody by 1 gets me to subtract 1 from both sides. You get n starting at 0. -1 to the n plus 2, I guess, which we had said earlier in the previous video that -1 to the n plus 2 behaves the exact same way as -1 to the n. So might as well put it in simpler form, because if this is odd power, if this is even, this is an even power. So it toggles back and forth the same way. N plus 2 over 2, I guess, and n plus 1 x to the n should give me my h of x representation as a power series. So if I open up my power series, it looks like this polynomial going on forever and ever captures this guy, but only for radius of convergence equal to 1 because we used our basic geometric series x to the n business to come through and finally get to this destination. So again, if we go and see if that actually makes sense or not, because we did all this business, what if we made a mistake in the process? We have this graphed. You can graph that on your TI if you want, and then put in a bunch of partial sums, maybe go up to a third or a fourth degree polynomial and see if it really captures this guy in the interval that you found. So here in purple I have 1 plus 1 plus x to the third, 1 over that to the third. If I only look at the first partial sum, I only get this constant 1, which again just gives me this line going through 0, 1. If I go up to the first one, it gives me 1 minus 3x, steeper slope in the negative sense, negative 3, trying to capture this piece of the curve. If I go to a second degree, better. Third degree, capturing a little bit more of it. Fourth degree, again going out further in your interval. Fifth degree, sixth degree, and so on. In this interval -1 to 1, and up above here it looks like it captures it even better. It keeps capturing the polynomial, so it looks like the power series I have does capture this polynomial in that radius of convergence of 1.